So we want to use the same case with the trapezoidal rule, isn't it? So you've been told to use trapezoidal rule with 6 intervals to evaluate the integral from 0.2 to 0.8 of x dx all over square root of 1 plus x cubed, isn't it? So for you to evaluate the area under this, as we've explained with the mid-ordinate rule, you need to know how many intervals am I dealing with, and how many intervals and how many ordinates, isn't it? Are we together? So you've been told 6 intervals, and you know each interval has its own strip or part, isn't it? So 6 intervals means 6 parts, 6 strips will be the same as 6 intervals, because each interval has its own part. And what did we see? The number of ordinates were more than the number of strips, isn't it? So if strips are 6, how many ordinates are those? 7 ordinates in trapezoidal rule. The number of ordinates are more than the number of strips by 1. We've seen that, isn't it? Are we together? So if the strips are 6, it means 7 ordinates. So we've seen what we are going to deal with, isn't it? After that, if there are 7 ordinates, you come and list those who are 7 ordinates, isn't it? They are going to be y0, y1, y2, y3, y4, y5, y6 is the 7th one, because we started with y0, isn't it? Are we together? So these are the ordinates we are going to get. So the next thing we need to get is what? Is h. Because h is the interval, each interval, isn't it? We need to get is the h. So you can see, you are starting from 0.2 and you are ending at 0.8. So from 0.2 to 0.8, what is that interval? 0.8 minus 0.8, meaning the whole of that rate is 0.6. So this 0.6 is divided into how many equal intervals? Into 6 equal intervals. So 0.6, if you divide into 6 equal parts, each part is going to take, isn't it? So it means h is 0.8 minus 0.2 divided by the number of intervals. How many intervals do you want? Divided into 6 equal parts, isn't it? So into 6 equal intervals. So each interval, the size of each interval is going to be, isn't it? So if you divide into 6 equal parts or 6 equal widths or intervals, you get your 0.1. So you found h. After getting h, we get x naught, isn't it? X naught is the starting point. So you know, in trapezoidal rule, we are starting at exactly that point, isn't it? So we are starting at exactly 0 point. If it is mid-ordinate rule, is when we are looking for it, isn't it? But trapezoidal rule, we are starting at exactly that point, 0.2, isn't it? So that when you are now going to get x1, you are simply going to add h to x0 to get x1, isn't it? You add h to x1 to get x2, isn't it? So we found x0 is exactly that point in trapezoidal rule, isn't it? So x0 is equals to 0.2. After that, we get our y, the function, isn't it? So the function y is when you remove this dx, whatever is remaining there is y, isn't it? Because when you are looking for area, you are integrating f of x dx. And if y is a function of x, where there is f of x, if you put your y, you get y dx. So it means the whole of that is y. If you remove dx, whatever is remaining there is the y, giving you the function, isn't it? So what is y? It is x over square root of 1 plus x cubed. X over square root of 1 plus x cubed. So after that we found everything. You start by knowing the number of strips, and the number of strips will also, you relate with the number of ordinates in that given rule, isn't it? After that, you list those two ordinates you are going to use, isn't it? Then after that, we get our h. After getting h, you get the starting point. After that, you get the function from that integral, isn't it? Then now what do? You write the formula for the trapezoidal rule. So how do we get the area with the trapezoidal rule? So mid-ordinate was h, trapezoidal rule was a half h, isn't it? So it is a half h, then into sum of n's, isn't it? And what are the n's? Y0 and y? and y6. So the ends is y0 and y6. Then twice the minus, isn't it? So twice what is left? What is left is from y1 to y5, isn't it? So it is twice y1 plus y2 plus y3 plus y4 plus y5. So that is the area by trapezoidal rule. So it means what we need to get is these values of y's, and we already have, isn't it? Yes. So for you to get those values of y's, you form the table, isn't it? So this table has how many rows? Has the 7 rows for the 7 ordinates, isn't it? Yes. So can you form a table with 7 rows here for the x and the corresponding y coordinate? Seven rows. This is 1, 2, 3, 4, 5, 6, 7. Now, if you are not told the number of decimal places, let us just say it is always very convenient to use how many decimal places? 4 decimal places. Whether for significant figures is not very convenient, isn't it? Sometimes it can be 10 point something. It means you are only looking for 2 decimal places now, isn't it? So it means 4 decimal places is convenient. Are we together there? 4 decimal places is very, very convenient for a better approximation of the area, isn't it? When you are not told. But when you are told, like use to leave your answer to 4 decimal places, 6 decimal places, then in that case you use what you've been told, isn't it? Yes. So here we start. Our x naught we found to be 0.2. Then our h we found to be 0.1. So for us to get x1, x naught plus h gives us x1, isn't it? Are we together? So what is x1? 0.3. Then you move to x2. x1 plus h gives us x2, isn't it? Which is 0.4. Then you move to x3. x2 plus h gives you x3, which is 0.5. Then you move to x4. x3 plus h gives you x4, which is 0.6. Then you move to the next one. x4 plus h gives you x5, which is 0.7. Then you move to x6, isn't it? So x5 plus h gives you 0.8. So you will see that is exactly the last ordinate there. Meaning trapezoidal rule and Simpson's rule are using the first and the last ordinates, isn't it? But we don't rule you want to look for the starting point because they are in the middle, isn't it? Is that well understood? Very good. So once you have the x's, we now want to look for the y's. The formula of y there we have y is equals to x over square root of 1 plus x cubed. So it means when we want to look for y naught, you put y naught here, x naught will give us y naught, x1 will give us y1, x2 will give us y2, x3 will give us y3, x4 will give us y4, x5 will give us y5, x6 will give us y6, isn't it? So it means when we want y naught, where there is x, we also put x naught, isn't it? So what are we going to have there for y naught? X naught is 0.2 over square root of 1 plus your x naught cube. 0.2 cube. What does the calculator gives you? What do you have here? 0.1? 0.1992. Is that the same value up there? Is that the same value up there? 0.199? 199.2. Are we together? With you two, without calculator, we can never be together. So you don't need to nod your head. Okay? Then the next one, you remove you are not there. We want y1, isn't it? So when you put here y1 where there is x, you also put x1, isn't it? So we'll have what? We'll have x1, which is 0.3 over square root of 1 plus x1 cube. 0.3, you are 0.3 cube. What do you get to be the answer for y1?
0.2960.
0.2960, isn't it? Are we together? next one, your y2. When it is y2, where there is x, you also put x2. So if you substitute the value of x2 here, what you get with the answer for y2 in the same procedure. Where there is x2, you put the value of x2 is 0.4. 0.4, 0.4. What do you get to be y2? 0.38? 38? 78.
Yes.
Give the calculator to the next person. We now want y3. When this is y3, that is x3. So can you substitute the value of x3, meaning x3 is 0.5. 0.5 over square root of 1 plus 0.5 cubed. What do we get to be the value of y3? 0.4714. So can you continue with the same procedure and get me the values? What is y4? When this is y4, that means it is x4. So y4 will be x4 over square root of 1 plus x4 cubed. x4 is 0.6. 0.6 over square root of 1 plus 0.6 cubed. What do we have? 0.5441. Can you continue with the same procedure to get me y5 and y6? What is y5? 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 0.6040. Can you use the same procedure to get me y6? .6506. So I have found all the y's. I'm done, isn't it? So can you now get me the area? You go to your calculator, a half h into. You see the number of brackets which are here. Look here. You see when you go there and you put your half times h times 0.1, then you put into bracket the value of y0 plus y6, then plus 2 into y1. You see, a half h will be only for this part. You will have left that part outside, then you are getting a wrong thing. Are you seeing what I'm doing?
Yes.
Are you seeing how to get a wrong thing very easily? Without knowing. And you are doing the wrongest thing. Look at what is here. It is a half edge, then there is a bracket, this outer bracket, then there is a bracket, this smaller bracket. Then we have y0 plus y1. Then you close, then there is 2 bracket, y1 plus up to your y5 there. Then you close with the 2 bracket. It means this half edge will be for everything inside. You will not get it wrong. But if you want to make it more simple, why don't you start by getting y0 plus y6? Are you seeing that?
Yes.
So that you have a half edge into y0 plus y6. What is y0 plus y6? You get this value. .8 y0 plus y6. y0 plus y6. What is this value first bracket here? 0.8498. Then it is plus twice all this value. So 2 in bracket y1 plus y2 plus y3 plus y4 plus y5. What do you get? 2 in bracket everything. Look there, we only have a simple bracket. We just put 2 in bracket, isn't it? What do you get? What do you have? Add them. Add them. You're looking at the other side waiting for the value. You're waiting for the value. The 2 gentlemen. You know you are no longer gentle. It's because of what you are doing right now. 4.6 06 66. Is that the same value you have there? Is that the same value you have there? Okay. So what do we get here? So a half times 0.1. If you add the two values in bracket, what do you have? This plus this.
5.45.
If you add them, then you multiply by a half times 0.1. Answer times a half times 0.1. You've already worked out the whole bracket, isn't it? What do you have? 0.2728. Is that approximately the value you got in Melodinate? Go back to the Melodinate. What was the answer? 0.27. So they are approximately the same value because these are roots getting approximated areas which are very close to one another. There's a very infinitesimal error, isn't it? Are we together? It's only through integration where you get the exact area. These are approximated, isn't it? So that is how to get the area with the trapezoidal rule.